Computer Science Career Paths 2025. In 2025, computer science has evolved beyond traditional software development roles to encompass diverse career paths that reflect technological advancements and industry demands. As artificial intelligence, quantum computing, and blockchain technologies gain traction, professionals in this field are exploring new opportunities across academia, entrepreneurship, and specialized domains. The landscape of computer science careers is shifting rapidly, driven by innovation cycles that prioritize interdisciplinary collaboration over siloed expertise. This transformation creates both challenges and exciting possibilities for those entering or advancing within the discipline. Fundamental concepts reimagined. The core principles of computer science have been redefined through emerging technologies that challenge conventional paradigms. Traditional data structures now incorporate dynamic elements that adapt to real-time processing requirements in distributed systems. Algorithm design methodologies have undergone significant changes, particularly in machine learning applications where adaptive algorithms outperform static models in predictive accuracy. These adaptations require a nuanced understanding of computational complexity and optimization techniques. Quantum algorithms. The integration of quantum mechanics with classical computation opens new frontiers in solving problems previously deemed intractable, such as factoring large integers and simulating molecular interactions at atomic scales. Distributed computing frameworks. Modern architectures emphasize decentralized solutions that enhance scalability and fault tolerance, requiring developers to master consensus protocols and peer-to-peer communication mechanisms. Data representation techniques have expanded beyond binary formats to include ternary logic systems that offer advantages in energy efficiency and information density for next-generation hardware platforms. The evolution of these foundational concepts necessitates continuous education and skill development to remain competitive in an increasingly complex digital ecosystem. Emerging specializations in computer science. A multitude of specializations have emerged within computer science, each addressing unique technological needs and industry requirements. Cybersecurity remains paramount due to the exponential growth of cyber threats targeting critical infrastructure and personal data. Blockchain technology continues to redefine trustless systems, leading to specialization areas focused on smart contract auditing, cryptographic protocol design, and decentralized application (DApp) architecture. Artificial intelligence research has fragmented into distinct subfields including natural language processing, reinforcement learning, and explainable AI, allowing practitioners to develop niche expertise tailored to specific problem domains. Career paths in augmented reality, AR, and virtual reality, VR, require mastery of spatial computing fundamentals combined with user interface/UX design principles adapted for immersive environments. Growth projections for key specialties. According to recent reports from the Bureau of Labor Statistics, cybersecurity analyst positions are projected to grow by 35% between 2023 and 2033. This rapid expansion reflects increased investment in enterprise security following numerous high-profile breaches involving sensitive corporate data. For blockchain specialists, market analysis indicates a compound annual growth rate, CAGR, of approximately 68% through 2028. This surge is fueled by widespread adoption of decentralized finance, DeFi, platforms and non-fungible token, NFT, ecosystems across global markets. The demand for AI engineers shows similar momentum with employment projections suggesting a 42% increase during the same period. This growth stems from industries integrating machine learning capabilities into products ranging from autonomous vehicles to personalized healthcare diagnostics. Academic pursuits and research opportunities. Higher education. Institutions continue to expand their offerings in computer science research, focusing on breakthrough innovations that push the boundaries of existing knowledge. Graduate programs now emphasize hands-on projects combining theoretical foundations with practical implementations. Research areas under active investigation include neuromorphic engineering, which seeks to replicate biological neural networks using novel materials and fabrication techniques. Such work holds promise for creating more efficient computing devices capable of mimicking human cognition. Collaborative research initiatives often involve partnerships between universities and private sector organizations working together on cutting-edge developments like quantum error correction codes and post-quantum cryptography standards. Students pursuing doctoral degrees benefit from access to state-of-the-art laboratories equipped with advanced tools necessary for conducting experiments related to nanotechnology-based computing components and photonic circuits. Industry roles beyond software development. While software engineering remains central to many computer science careers, alternative professional tracks provide meaningful contributions without direct coding responsibilities. Technical project management roles bridge the gap between creative visionaries and execution teams by ensuring alignment with strategic objectives. Product managers play crucial roles in defining technical roadmaps based on customer feedback loops while maintaining awareness of market trends affecting platform evolution. Their decisions influence not only feature prioritization but also cross-functional team coordination strategies. Data scientists analyze vast datasets using statistical methods and machine learning models to derive actionable insights supporting business strategy formulation across various sectors. Their work impacts everything from marketing campaigns to operational efficiency improvements. User experience researchers conduct empirical studies assessing how users interact with digital interfaces. By identifying pain points through observational research, they inform design choices aimed at enhancing usability metrics significantly. Entrepreneurial ventures in tech innovation. Computer science professionals are increasingly turning towards entrepreneurship as a viable path for leveraging technical skills into commercial ventures. Startup incubators dedicated specifically to tech innovation foster collaboration among inventors, investors, and mentors. Successful ventures often stem from recognizing unmet needs within established markets or identifying underserved communities ripe for disruption via innovative product offerings grounded in solid scientific principles. Founders must balance technical depth with business acumen when developing value propositions compelling enough to attract early adopters and secure funding commitments from venture capital firms specializing in tech startups. Building scalable infrastructures requires careful consideration of cloud computing architectures along with automated deployment pipelines essential for agile software delivery processes typical in modern startup environments. Global perspectives on computer science careers. Variations exist globally regarding preferred career trajectories within computer science disciplines influenced by regional economic conditions, regulatory frameworks, and cultural attitudes toward technology adoption rates. Developing nations may place greater emphasis on information technology, IT, services outsourcing as part of their national economies compared to developed countries investing heavily in R&D activities related to fundamental computing theory advancements. Cultural differences impact workplace dynamics affecting interpersonal relationships among colleagues from diverse backgrounds engaged in collaborative efforts spanning multiple time zones through virtual meetings conducted online regularly nowadays. Regulatory environments vary considerably, influencing permissible uses of certain technologies. For example, facial recognition systems face stricter scrutiny in Europe than elsewhere due to stringent privacy protection laws implemented there recently. Maintaining competence through continuous learning. Given the accelerated pace of change within computer science fields, lifelong learning becomes imperative for staying current with evolving best practices and newly introduced technologies continuously reshaping our professional landscapes. Online learning platforms offer flexible options enabling individuals to acquire new competencies irrespective of geographical constraints limiting access to traditional educational institutions otherwise required historically. Certification programs serve dual purposes, acting both as formal validations confirming proficiency levels achieved while simultaneously providing networking opportunities connecting participants with peers sharing similar interests. Participation in open-source communities provides exposure to real-world problems encountered daily by developers worldwide, thereby offering invaluable hands-on experience applicable directly to future job functions pursued subsequently. Conclusion. As we approach mid-decade mark in 2025, Computer science offers unprecedented variety concerning potential career directions available today more than ever before in its history so far. To thrive professionally within this vibrant domain requires proactive engagement with ongoing developments characterized primarily by rapid iteration cycles demanding flexibility, adapting quickly whenever necessary circumstances dictate, doing so effectively.